lecture, we're going to explore how climate change directly affects agriculture and also some of the indirect effects. I'm going to start off with explaining some of the basic processes through which climate impacts on plants, and then we're going to look at projected impacts of climate change on agriculture over Africa. Fundamentally, climate operates or affects plants through photosynthesis. And photosynthesis itself needs light, temperature, water, and nutrients to occur, and it's through photosynthesis that plants build up the sugars that they need to grow with. Generally, if it's warmer, you get faster photosynthesis, and that leads to faster plant growth. But you reach a threshold or a tipping point where if it gets hotter and hotter, photosynthesis is reduced. So warm, extreme temperatures like we get over much of semi-arid and arid Africa actually lead to reduced photosynthesis. That's why you don't get plants in deserts, for instance. Climate also affects photosynthesis through water stress, and that is in three main ways. The first is through the effect of water shortages on the photosynthetic reactions in the leaves themselves. So when there's a shortage of water, the reactions that use water in the leaves are slowed down, and so photosynthesis slows down. The second is through plants wanting to reduce their transpiration when they're under water stress. And the way they do this is they close or make the pores on their leaves smaller than they were, so that they lose less water through the leaves as transpiration. But at the same time, that means that less carbon dioxide can be brought in from the atmosphere into the leaves for photosynthesis. And so that therefore acts as a limitation, a carbon dioxide limitation on the rate of photosynthesis. And then the final way that water affects plant growth is through waterlogging. So if you have too much water in the soil, that actually reduces the effectiveness of the roots and all of the microorganisms that are working with the roots to bring nutrients into the plant system and slows down growth. One of the important things to note is that those direct impacts of heat on photosynthesis become much worse when a plant is under water stress. So say you had a day when it was 40 degrees. If the plant was short of water, the impacts on its growth would be much worse than if it had sufficient water to continue growing. These impacts of heat and water stress vary across different stages of a plant growth cycle. So early in its growth cycle, when imagine you've got a seedling that's establishing itself, heat stress and water stress can really cause damage to the root system, and that then has knock-on impacts throughout the crop cycle, because if you have weak roots, the plants are unable to access the water and the nutrients that they need to really grow as effectively as they can throughout their growing season. If you have similar stresses during the flowering period, then you can end up with much lower amounts of flowering than you'd hope for, and that has knock-on effects on fruit and therefore the yields of these crops. The important thing to note is that these impacts of heat and water tend to occur at certain thresholds. So if you have a cumulative buildup of heat or water stress, after a while you get a collapse in the yield of the crop or complete failure. Weather and climate also have other impacts on farming systems. One of the most important is through rain and hail damage, and that's particularly, again, critical at certain stages. So the first stage is in the seedling stage, where if you have a heavy rainfall event, you can have all the seedlings washed out of the soil and then you lose your whole crop. And also again in the flowering stage, that's really important. So hail damage when your crop is flowering can knock all the flowers off the crop, and then you'll have no produce. And then rain, and particularly hail damage and sunburn, can affect the quality of your fruit as well during the ripening stage. Climate also affects pests. Many of the big pest outbreaks that cause widespread crop damage are at least triggered by climate. So locust infestations can be driven by a rainfall period that then lets all the dormant eggs hatch and produce a plague of locusts, and various other pests like, for instance, mildew, which infest many plants, are exacerbated in cool and wet periods. seems a bit strange in Africa, but you can also get cold spells that can cause damage to crops. So in areas where you might have a cold winter and you plant at the beginning of the spring season, if you have an unseasonal cold spell, you can get frost damage that damages the seedlings and then leads to crop failure. Moving on to livestock, climate really affects livestock directly, both through heat and water stress. So heat stress really affects livestock mostly by making them want to seek out shade. And by seeking out shade, they spend less time foraging and eating, and their nutrient inputs decrease. And that can both sort of lead to weight loss and poor health of the animal itself, but often leads to pregnancy terminations. So pregnant livestock, when they're under heat stress and then nutrient stress, will often abort the pregnancy, and you can have quite serious impacts on stock numbers through that process. Water stress, well, obviously you don't want thirsty animals, it's not good for them, but secondly, when you do have water stress or water shortages, animals tend to then collect and coalesce around the few water points that are remaining, and they have to travel further and to get food. And so an indirect effect of water stress is a lack of or reduced feeding because of overgrazing in and around these water points. And then finally, indirectly, I guess, if you have a drought, then that impacts on the fodder that's available, the food that's available for livestock, and that can obviously then have knock-on impacts into the health of the livestock. In the lectures on water, we talked a little bit about how carbon dioxide levels affect water use of plants. This is a part of a process known as carbon dioxide fertilization, and it's another physical process by which climate change, in this case the cause of climate change, increased levels of carbon dioxide, can affect plant productivity. Basically, rising levels of carbon dioxide stimulate photosynthesis. This occurs because many plants are limited by the amount of carbon dioxide that's available in their leaves. The rate of photosynthesis is limited by the concentrations of carbon dioxide. So if you increase levels of carbon dioxide, then it makes it easier to photosynthesis, and photosynthesis can progress faster and plants grow faster. This carbon dioxide fertilization effect, though, can only happen if it's not limited by other factors, such as the availability of nutrients or the availability of water or heat stress, as we've talked of before. The strength of the carbon dioxide fertilization effect varies between different plants. So, for example, two very important crops, wheat and potatoes, the effect is quite strong, in fact, and can make quite a big difference. Whereas maize and sugar, for instance, are less affected by carbon dioxide fertilization because they're already quite efficient in the way they use carbon dioxide in their photosynthetic processes. There's been quite a lot of experimental evidence around this carbon dioxide fertilization effect, but much less of what actually happens in real-world conditions. But what is emerging is that the effects of CO2 fertilization are highly variable. They're both location-specific, dependent on crops and the type of farming system, the water availability, soil types, and a whole range of other factors. But the net effect seems to be a slight positive effect. So it's kind of one good message, if you like, in terms of agriculture, is that although carbon dioxide is going to cause climate change, it's also at the same time going to enable plants to be slightly more productive in this future climate.